Thank you. How's everybody doing today? Good. Like you said, I'm from Michigan. I actually drove here, so what we like to say is we're from here. Nobody got that joke. Well, maybe 5 people got that joke. Thank you. Thanks. So I know a lot about Canadians and like stereotypes. I've been here a few times. But one thing I never thought when I came here was that I was going to see professional wrestling fans. That's not what I think of when I think of Canadians. But, that was a nice surprise, I guess. So today we're going to talk about getting started developing server-side Swift with Vapor, and specifically Vapor. I want to cover today why you'd want to use Vapor in your server application or for your backend. We'll talk about getting set up on your Mac to start developing for Vapor. We'll then talk about how to get a route set up, so how to get your API going in Vapor. Talk briefly about middleware, but a lot of the guts of the application will be talking about database queries, because who doesn't run a server app without some sort of database interface or data layer? And then lastly, I'll talk about deployment. So why would you go about Swift or server-side Swift? And I feel like I hear a lot of the kind of murmurs of this with Swift UI. Like there's always a new technology out and everybody is like, yeah, let's just convert everything to Swift UI. Like, no, that's obviously not the case, especially with a beta that's pretty limited as far as what devices it can be on. And I would say that goes the same with Vapor. I really like Vapor, but I'm not going to recommend anybody rewrite their server apps into Vapor today. Absolutely not. Or in the next 6 months. I don't think that's a good use case for Vapor. What I would say is if you're starting a new project and your team is already developing a lot of their code in Swift, that's where Vapor is a really good fit. You have a brand new iOS app or Mac or iPad or whatever, and you need a backend for it. Vapor, I think, is a really great choice. As we'll talk about later, deployment is pretty simple and easy to get going. So in that case, I would say, yeah, it makes sense to switch over to Vapor. I also think that if you have some sort of outdated architecture, you're using, like, let's say, old PHP code or old Java code, and you're already in the midst of saying, yeah, this is not, we're putting this on strings and tape, like we need to move to something new, that is also an opportunity, assuming your team is already well-versed in Vapor. It makes complete sense. I will say the competitor to Vapor is Katura, which is done by the IBM team. I think that is a great alternative if you're in the enterprise. As you may imagine, IBM is heavy in large-scale businesses and enterprise. Katura is definitely much more focused on the things and concerns that the enterprise are concerned about, downtime and error logging and things like that. That's where I think Katura shines. As far as everything else, Vapor is a robust, dynamic, open source community. And I think it's easier to get up and running right away with Vapor. And I think most people probably should go with Vapor if they are going to go with server-side Swift. So we talked about the reasons. How do you today actually get started? A lot of you have your MacBooks with you. Well, it's actually not that difficult to get started, and you could do a lot of the development in Xcode. What the Vapor team has given us is a tool set available to us that will allow us to essentially kind of do what Swift Package Manager does, but it does a lot of the hand-holding that you don't need to do to get Vapor as part of your Swift package or your server application. So if you're familiar with Homebrew, they use Homebrew to allow you to install it. There's probably manual ways, but for 99% of you, I think Homebrew is probably the best way to go. So if you tap their Vapor repo and then you install it through Vapor, you'll get a command line tool that'll allow you to get started building essentially a Swift package, but also an Xcode project as well. So let's talk about actually creating a project. So Vapor, like I said, command line tool, they have a subcommand new. You say whatever name you want for your new server-side application, and you have a directory with a Swift package available to you right away. Even though I have already started using Xcode 11, and Xcode 11 has support for Swift packages, I would say that the Vapor apps don't work as Swift packages within Xcode 11. So I would recommend you create a Xcode project out of that Swift package. That's where Vapor Xcode comes in. It basically does a little bit more work than what you'd get out of generating Xcode project with Swift Package Manager. but it will essentially create the code and targets and schemes that you need in order to get started. So let's talk about the structure of a Vapor application. So you'll get a couple of packages, a couple of targets, an app target and a run target, and the run target is what really runs the application and basically starts opening that WebSocket so you can start serving. But there's really 4 components that you're going to edit when you edit a application. There's the controllers, which is where you basically have the bulk of your logic code. So you'll set up a controller for, in this case, we're going to do a to-do list. So you'll set up a controller for to-do items and be able to do your get, read, list, all your CRUD applications in there. You also have your models. A lot of times these could be database models, but it could be all sorts of models. But essentially, this is where the structure of your data items will be. You have configure.swift. That is where you set up middleware, you set up your database. You're basically configuring your server application in here, setting up services and things like that. And then lastly is what's called routes.swift, which is going to return, it's going to hook up your controller to your server, so that way you can specify certain API paths within your application that'll actually hook up to the controller methods. So let's talk about setting up a route. So here's an example of a piece of code in routes.swift. So we instantiate our controller, and then we set up the get call for our to-dos, so basically listing out our to-do items. We set up our post to create our to-do items. And then we have a delete here, which you'll notice takes in a, each parameter is essentially a slash within the URL path, and the last one that has use is the path to the method or to the function. So to-do.parameter will automatically look at the ID within to-do/1 or to-do/2 and automatically look for that to-do item and then allow you to delete that from the database, which is really neat. So here's an example of a method within the to-do controller. So here we have the list method for to-dos. This will list out the methods. And all we have to do is we grab the model, in this case to-do, and we query to-do. We have to pass in what's called an event loop. In this case, the request is our event loop. It's kind of like a thread, but a little bit more abstract than that. And then we return all the items. Notice here, we're not doing any decoding to JSON. None of that stuff has to be done. It's done automatic, assuming you implement certain protocols within your model, which you typically would do. So briefly, I want to talk about the middleware that's available on Vapor. So you have the ability to serve static files with file middleware. And then you also have the ability to customize errors and throw certain HTTP errors using the error middleware. I want to note those, but I think the bulk of what you're going to work with is databases. So let's talk about that. So there's really good database support in Vapor right now. It currently supports, just from the Vapor team itself, MySQL, Postgres, Mongo, and SQLite, which is the default when you create a Vapor project. And what they do is they have an ORM called Fluent, which it's an abstraction layer that allows you both to create the database tables and relationships, but it also gives you an easy way, a Swifty way, to access and query the database and be able to do all sorts of manipulations that you would typically do with a database or a database table. So let's talk a little bit about how to set up models within Vapor. So let's take a look at our to-do model, for instance. You can see here we have 2 properties on our model for a to-do item. We have an ID and a title. You'll notice the ID is actually optional. The reason for that is that your ID is a primary key that's automatically created. So when you first create your to-do item, you're not going to have an ID because it's not been saved yet. So that is why ID here is optional. You'll also notice we're deriving off of the SQLite model. If you switch to another database, you just simply have to switch to a different subclass. But it gives us a lot of the code that we're going to need. What to-do needs to do is it needs to implement a migration protocol, and there really is no custom code needed. You just have an extension that implements migration. which we'll show in a little bit. And what that'll do is that'll allow us to set up migration configuration, and that migration configuration will then automatically create that table if it doesn't exist when you first start up your server. So we have here migration configuration, add the model for our to-do items. We're going to be using SQLite, register it, and it goes along with a lot of the other middleware that we'll set up with our application. So let's talk relationships. Not personal relationships, like database relationships. So I want to take my to-do items and I want to put them in like a project. I want to say these to-do items are part of a project of some sort. So we're going to create a new model. In this case, we're going to create a model called project. So same thing, we just have a title and ID. Pretty much looks exactly like the to-do item. But we're going to need to change a few things with to-do. But before we get that, here's an example of extending or implementing migration. In this case, we don't have any custom code. We just say it implements migration and does all that code for us. Kind of think of it like how you do Codable. Like 80% of the time, you don't need to have custom code in there. Here, I want to note we have project added first into migration. This is important. If you don't have your models in the correct order, you will have an issue. Our to-do items will actually be dependent on the project table, so we need project first, and then we add the migration for to-do items next. There we go. You might be wondering, how do you automatically set up parameters? So you saw to-do.parameter, and you also saw that we returned a to-do item in a list. All we had to do was implement parameter and content, and as you can see, no custom code, simply like Codable 80% of the time. It'll work right away. Where you're going to need custom code most of the time is when you do migration. So in this case, we needed to override the prepare method on to-do because we're adding a new field. We're going to add a new field called project ID. This is an optional field, and it essentially says that that to-do item's parent is this project. And we create the field for the ID. We say that that ID is the identifier or primary key. And this all uses KeyPass pretty easily. We don't need to say what type. You can say what type if you want to, but it's not necessary. It'll automatically look at the Swift type and create that table column according to the Swift type. We have a project ID. And then the last piece of code, and the code that we need when we do migration, is we need to say that the project ID refers back to the project ID on the to-do item refers back to the ID of the project. In other words, a foreign key. Since project ID can be optional, we, rather than have it delete the to-do item, essentially like a cascade is what you'd call it, we just wanted to set it null. So if you delete the parent project, we tell it that the to-do item will no longer have a project attached to it. So now we go ahead and recreate our routes. So here is an example of the project controller. So we have here our list, returns our list of projects. It just basically queries the database for all projects. You can see here, we don't have to do any JSON decoding or encoding. It automatically returns those projects in JSON format. Here we create, so we have to decode the JSON. No manual JSON decoding here. It just automatically creates that project. And we call Flatmap, which I'll explain a little bit. But essentially, we take that project that's been decoded and we save it to the database. Lastly, for our delete, we take in the project ID as part of the URL. So you can see here request.parameters.next project self will automatically look for that project based on the ID. And then we call project.delete on the request event loop, and it'll go ahead and delete the database. If it's a success, we return an OK or HTTP OK 200. So here's our routes file. This is where we're mapping the URLs to the code in controllers. In this case, we have our list, which is just going to be a get call to projects. We have a post that takes in JSON and creates a new project. And then we have delete, which takes in a project ID and deletes it from the database based on the project ID. So one thing I really want to talk about that's super important when it comes to Vapor is understanding futures and promises. I think big backbone of Vapor is understanding this and how they implement this in Vapor, as well as its underlying technology, which is Swift Neo. So you probably have noticed there's two calls, a flat map and a map. How many of you have worked with Flatmap on an optional? Okay, cool. So it's the same idea, essentially. When you're making a synchronous call that just returns a value, you'll want to use map. When you're making an asynchronous call that basically is going to return a future, you need to call flat map. Because what you'll end up running into is future, which is not super helpful. If you've dealt with double optionals, it's a pain in the neck. Luckily, we have flat map that will flatten the future, so it's just one future value. And then map will take basically a synchronous function. We'll talk about that, show examples of that in a little bit. Another case is where you either have a set of futures that are either the same type or different types. And that's where and flatten comes in. So and will take a future A and a future B. And if you call that, it will give you a future AB with a tuple. If you do flatten, a lot of times you're going to do like an actual map on an array call, and you get a bunch of futures, but you actually want to flatten that, and so that rather than it being an array of future, it actually is a future of an array. So luckily, flatten does that for us, which is really useful when you are trying to do advanced queries on the database. Assuming you have the error middleware, you can also deal with errors in a special way. You can say, for instance, this error, the specific guard else statement will return a 401 or a 404. You have that ability to customize HTTP errors according to what you think is correct as far as the REST API is concerned. So we're going to go ahead and create an actual custom response. I don't like how we have index where it returns an array of projects, but I actually would like it to have one where you can say project 1 or project 2, and it actually returns the child to-do items. That'll give us an opportunity to get a little bit more in depth into futures and promises and how relationships work. Luckily, Vapor comes with some built-in functions like children and parent, as well as a children and parent generic type. So that way we can actually automatically access, for instance, the parent project of a to-do item, but also we can access the to-do items of a parent. This is pretty awesome. It makes it a lot easier to do joins if you need to for foreign keys. They also have available siblings when you do a many-to-many type mapping as well. But in this case, we're just doing a one-to-many. So here's an example of customized response type. I don't like how to-do has a project ID, so I got rid of that in this response type. This is a separate type, completely different. And then I want to create a new project response type, which then has basically an array of to-do child responses. This is going to be a lot easier when we have somebody get a specific project from the database. So here's an example of how we'd go ahead and do that. Request.parameters, grab the project ID. So you can see here, project parameter is the last piece of the URL. So we can just grab the project based off of the ID or parameter. We then call flatmap because we're making a database query that's asynchronous. And then after that, we need to take the project that is returned. And since this is also a database query to get the to-do items, that has to be a flatmap as well. We then go ahead and grab all the to-do items of that particular project. And then we return a response. We have to do try because we're calling here what's called project.requireID. All models have a require ID, which will throw an error if it doesn't have an ID or has not been saved yet. We then grab the title of the project, and then we call the actual array.map to then convert each one of our to-do items into a to-do child response. So what if you want to add a relationship? So in other words, you want to add a to-do item to a particular project. How would you go ahead and do that? Well, here, if you look at the bottom, we have a post call, which takes in a project ID and a to-do ID. What we're going to do is we're going to grab the project ID by using the first parameter, checking that there's actually a project, and that project, of course, has an ID, which 99, I hope it does, if it's saved to the database. And then next, we're going to grab the to-do ID, use that to grab the to-do item that we're referring to. we are using and to form a tuple because we want both of these objects at the same time. So we get a tuple with the to-do item as the first part of the tuple, and then the project ID as the second part of the tuple. And then all we have to do is set the project ID property on that to-do item to the project ID of what was passed into the URL. Again, we save it, and then rather than returning a particular object, we just want to return HTTP status OK, that it worked, and that we added that to-do item to the project. So this is an example of how to use and in order to form a tuple. Just for completeness sake, I want to talk about removing a relationship. It's very sad. It's like a Facebook status change almost. Sorry. Really, this is probably the simplest piece of code that there is. So here, we don't even need a second parameter. We just need the to-do item and just tell it to remove it from whatever project it is. We just say request.parameters.next. We say that we want the to-do ID because that is the parameter we're looking for. We then take that to-do item and call flatmap because this is an asynchronous call to the database. And then we set the project ID to nil because we don't care what project it's part of. We just don't want it to be part of any project. Save, and then transform that to an HTTP status OK. So you've obviously figured out everything you need to know about database queries and setting up a URL request. Now, how do you get your app into the cloud? How do you actually deploy it? So there's two ways I'm going to suggest today. Heroku has a really great free service available that gets you a lot, including a Postgres database. You're not going to build the next Google with it, but you're going to be able to at least experiment and play around with posting things to the cloud and sharing it. So luckily, Vapor includes a Heroku subcommand where it'll automatically set up the Heroku instance. It'll add the build pack, and then it's just a matter of pushing that to Heroku in order to get your app running, and you're pretty much good to go. That's it. It's really that easy as far as Heroku is concerned. The other option is just run your own VM. I have an instance of Linode that worked really well. EC2, I don't care. But as long as you have Ubuntu, that's the primary Linux distribution, which works with Vapor. And then rather than Homebrew, what you're going to do is add the repo for Vapor, and using that curl command right there. And then as long as you're root, go ahead and install Swift and Vapor, and you're pretty much ready to go. If you're using something, typically you'd use something like Apache, right, or Nginx, and then proxy your Vapor through that. That's available to you. And the other suggestion I would make is have an application like Supervisor, which makes sure that your app is up and it's tracking any sort of errors or getting your app rebooted if necessary. But it's pretty easy to get set up on Ubuntu with that. So what's next? One thing is you probably want to switch to something like Postgres or MySQL for your database. That makes complete sense. It's not that much harder to switch to a new database, honestly. But obviously, these database systems are a lot more robust. If you're going to deploy it to the cloud, you probably want to use some sort of environment variable to keep track of your database connections and where they belong. Like you're going to use a specific URL that Postgres provides, obviously, or Heroku provides. Or you might want to have a different username and password and database name on your Ubuntu instance. That is all stuff you'll want to look at, and they provide an environment API in order to do that. We can get even more into like WebSockets, or of course, no application is complete without some form of authentication. Luckily, Vapor provides that for you. And that's another thing that you can do to take your application to the next level, make it a little bit more professional. They offer basic, digest, OpenID, OpenAuth, all those methods available to you. And then we just touched the surface with getting a list of projects or getting a project with to-do items. But there's even more you can do with queries, a lot more advanced stuff. We didn't even get into joins and filter and things like that that are available to you within the Fluent ORM. So that's something to consider, especially when it comes to managing particular promises or futures. You're going to want to make sure that you line that stuff correctly so that everything runs in the correct order. Before I end, just a few key takeaways. I think Vapor is pretty solid if you're going to run a brand new server application and you're already pretty adept with Swift. If anything, there's Xcode compiler errors that don't make any sense, but like if I had $1 for every time I've run into one of those, like I wouldn't need to have a job, right? So like you're going to run into that with iOS development. You're going to run into that on the server as well. But I think it's not any reason to not do server-side development. So we've talked about how to set up your Mac. Pretty easy. Just install it from Homebrew, and you're good to go. Run it. You run the run scheme or target in Xcode, and you have a server application running within Xcode. We talked about setting up a database with models using Fluent RRM and being able to do more complex stuff like relationships, one-to-many relationships in the case that we did. We created our first set of REST APIs for projects, including how to take a project object and map it to a more useful response for our client. We talked also about how to deploy to Heroku or Ubuntu as well. Pretty easy to do. I've only dabbled very little in Docker, so I don't really want to talk about that, but I'm sure it'll work just as well. There is a Docker image for Swift that you can get started with as well. If you want to learn more, go here, and I will send you my blog article about deployment and how to get more into deployment and converting your app over to Postgres as well. You see my Twitter handle right there. You have my email address and my blog as well. Thank you very much.